This is a different data set than the one you'll be using for your problem set. This is a real sample of 60 respondents from the CDC's Behavioral Risk Factor Surveillance System, a national health survey. I want you to see these same Excel skills applied somewhere new, so you're practicing the thinking, not just copying what I did when you do the problem set. Now, before we build anything, let's look at the data. So column A is a self-reported general health, which they describe it as 6 categories. B, C, and D are yes or no health behaviors. Um, E is the height in inches. F is the weight in pounds. G is the weight that they want to be or that they desire to be, also in pounds. And then we have age and gender. And we have starts observations in column 2 and go or row 2 and goes down to row 61. So we have 60 observations or 60 people in this survey. Now we're going to focus on 2 variables here today, weight and height. In the problem set, you'll be using this with different variables. So let's start looking at the center of the distribution. We'll just put some descriptive statistics here off to the side so that we can see the columns and the rows that we're working with. So let's start with the height and the weight. And right here, we'll write mean. We're looking for the mean first. Like equals average, parentheses, and let's select for height from row 2 down to row 61. And do the same for the weight. Only this time, let's type it in. So F2 colon to tell us to do all of the cells in between to F61, which is the last observation. We can scroll down and double check. Yes, that's the last one. And then hit enter. So we see the average weight in the sample is about 173 pounds, and the average height is about 67 inches. That's about 5'7". So now that we have the mean, let's look at the median. Like the median here. So equals median is our function. Let's start with height, go all the way down. And then the median for the weight. So type in median F2 colon F61, just like we did before. And we can double check again to make sure we're not making simple mistakes. So we have the median for the height is just about the same as the mean for height, but the median for the weight is noticeably lower than the mean for weight. So now let's calculate the standard deviation. We need to put that in the next tab. Standard deviation. So equals STDev. And like last time, we want to select S because we're working with a sample. So starting with height, we'll do E2 down to E61. And equals STDev S. And then select the appropriate observations in the weight column. Now remember, for standard deviation, Excel has the 2 options. We selected the sample here because this is simply a sample. It's not the entire population that the survey is trying to describe. So now let's get the rest of the 5-number summary, and so we can figure out some of the boundaries to create that box plot. So we can put in the minimum here. So equals min is what we want to type. And then we will just select the height column. Type min again, and then go to the weight column and do the same thing. And this will tell us the minimum value or the smallest value. Next, we can type in the first quartile, the Q1. So to find that, we type in equals quartile, select the column that we want. Then this it's telling us the array, so that's the observations here that we selected. Then you have to type in a comma and then the quartile that you're looking for. So comma and then 1 because this is the first quartile. And we can do the same thing here. quartile, select the data that we're looking for. So this is the F2 to F61, comma 1, and we have the first quartile. Now, we already have the median here, which is the second quartile, so we can skip to Q3. So for Q3, we're going to basically do the same thing, equals quartile. We select our data for height first, comma, and this time we do 3 because we're looking for the third quartile. And we will do the same for weight. Select the data, comma 3, and there we go. And now we want to select or find the maximum value. So type in here, x equals max to our column, and then do the same for weight.